Solving rational inequalities is a lot like solving a polynomial inequality. There's really just one thing that you have to watch out for. So again, we solve a corresponding equation. We draw a number line. We mark any values for which the denominator in the inequality would be 0. Those can never be a solution to the inequality. This is the big difference between solving a rational inequality and solving a polynomial inequality. So then, we take any solutions from the equation and we mark them on that number line. Between steps 3 and 4, we now have intervals created. And as before, we choose a test value on the interval. And if that test value, whenever we substitute it into the inequality, makes a true statement, then that interval corresponds to the solutions. So let's go ahead and solve this corresponding equation. X minus 4 over 2x minus 6 equals 1. If we multiply both sides by the denominator, we get x minus 4 equals 2x minus 6. If we subtract x from both sides, we get negative 4 equals x minus 6. Add 6 to both sides, we get 2 equals x. But now, let's go ahead and look at any values for which the denominator would be 0. So we get 2x minus 6 equals 0. That would yield x equals 3. So let's draw our number line. X equals 2 is a solution to the equation. And then x equals 3 is not allowed. So what I'm going to do is I'm going to make a hole there at x equals 3. Just to remind myself never to allow that value. So now we have 3 intervals. Let's check. So we can choose 0. Between 2 and 3, we can choose, say, 2.5. And to the right of 3, we can choose 4. Let's substitute these values into the original inequality. Substituting 0 in, we get 0 minus 4 over 0 minus 6. That's negative 4 over negative 6. That's 2/3. And 2/3 is less than or equal to 1 is the inequality. That's true. Now, let's choose 2.5 to be substituted into our inequality. That gives us 1.5 or 3/2. So, 3/2 is less than or equal to 1. That's false. What happens if we put 4 in? We obtain 0 over 2, which is 0. So 0 is less than or equal to 1. That's true. So let's now shade anywhere that it was true. So we're going to shade to the left of 2, to the right of 3. Now, let's look at endpoints. 2. Can 2 be included? Well, 2 was the solution to the equation. Do we want equality? And the answer is yes. We allow for equality because of that equal bar. So we'll use a bracket. Now, what about 3? Well, 3 can never be included because it would make a denominator 0. So this tells us that our solution is negative infinity to 2, include the 2, union 3 to infinity. Now let's look at this. To solve this equation, or to solve this inequality, we solve the corresponding equation. And we can cross multiply. So I can multiply the 4 and the x plus 1, and the 2 and the x minus 7, and those should be equal. So we obtain 4x plus 4 equals 2x minus 14. Subtract 2x from both sides. subtract 4 from both sides. So x would equal negative 9. Now, where would denominators equal 0? That would mean x equals 7 or negative 1. Those need to be excluded. So let's draw our number line. So we have negative 9 as a solution to the equation. We have then negative 1 and 7 that need to go. So negative 1 and 7. So now we have 4 intervals to check. And we'll check each interval with a test value. And we substitute those test values into the original inequality to see if we obtain a true value, or a true statement or a false statement. So go ahead and pause the video, plug these values in, and see if you get true or false for each interval. So we obtain false, true, false, true. So where do we shade? We shade where it's true. Now we need to check endpoints. Will we let x be negative 9? Well, negative 9 makes it equal. We do not have equality here, so we cannot include negative 9. Negative 1 makes our denominator 0, so we cannot include that. Likewise, 7 cannot be included. So we have our answer is negative 9, comma, negative 1, include neither, and then from 7 to infinity, include neither.